Hello and welcome to the video for section 11.1. This will be the first video of two videos. In chapter 10 we're going to be looking at what's known as conics, specifically the parabola, the ellipse, and the hyperbola. In 11.1 through 11.3 we'll just be looking at those three as if they're centered on the origin. In 11.4 then we'll shift them, much like when we first learned about the circle. We talk about a circle at the center at the origin, and then we can move it around the coordinate plane. So the chapters or the sections will all start out the same. So the first thing we're going to do in 11.1 with regards to the parabola is the geometric definition. So for a parabola, we have the following. A parabola is the set of all points in a plane that are equidistant from a fixed point F and we call this the focus. And a line I and we call that line the directrix. So what this means graphically, and you know what a parabola looks like, but what geometric definition does it have? Well, let's assume that we have this parabola. So at the bottom, we have the vertex. And we have some point up in the middle here known as the focus. We then have another line outside of the parabola. This is known as the directrix. And so what the geometric definition is saying is that if I go from the focus out to the parabola, and then from the parabola straight down, and so I didn't draw this to scale very well. Let me change that up so we know what we're doing here. So if I go to the focus of the parabola and the parabola down to this line, the directrix, then the lengths of these blue segments, so this one here is the same as the length there. That's what the geometric definition is. So no matter which way I go, if I go off to the right, hit the parabola and come straight down, these two lines are of equal length. That's the geometric definition of the parabola. And as I said in chapter 11.1, 11.2, 11.3, the vertex, in this case, will be centered at the origin. So, I'll give you guys this information now. The parabola with the vertical axis is what you guys are used to seeing. So that would be, the axis is the line that cuts the parabola in half. And vertical meaning straight up and down. So again, that's what you're used to seeing. So the property of that is as follows. So parabola with vertical axis So this is the graph of x squared is equal to 4py. So that 4py has different meaning. So this is the graph with this equation, and this is a parabola with the following properties. So again, as I mentioned, the vertex is at 0, 0. The focus is the point F that 0 has coordinates 0 and P. So that tells us how far up or down we're going from the origin. It has directrix with equation what? Well, for a horizontal line, our equation is always y equals a. But in this case, because we're p units away from the vertex, the directrix has the equation y is equal to minus p. And then the focal diameter is the absolute value of 4p. So focal diameter is from this focus. If we go out to the parabola horizontally, that gives us the length of the focal diameter. And then lastly, it opens up if p is greater than 0, and it opens down if p is less than 0. So let me go ahead and have you get caught up with the writing there. So that's for our parabola with the vertical axis. Now we're going to introduce you to a parabola with a horizontal axis, so pointing left or right. So this will be new material for you. So parabola with horizontal axis. And so in this case, the graph y squared equals 4px. So right away, what do we see? Well, when we have a vertical axis, it's our x value that's squared. When we have a horizontal axis, it's our value, our y value, that's the squared term. A lot of the ideas are still the same, it's just now we're switching our x and y values. So again, our vertex is still at the origin, 0, 0. The focus, so in this case, the focus, we stayed on the y-axis. So we didn't move left or right, our x value is 0, but we move up or down. In this case, it's a parabola pointing to the left or right. So we're not going to move up or down, we're going to be moving left or right. So in this case, the focus is at the point P and 0. And the directrix, because now it has to be a vertical line, is x equals negative p, whatever that value for p is. Focal diameter is still the same, because we're talking about a length. So it's just the absolute value of 4p. And then it opens to the right. If p is positive, opens to the left if p is negative. So a lot of similar ideas to like our polar curves. If we have a minus sign, it's moving left or down. Same idea here with the values for p. So that's our general information for the equation of a parabola. That's the end of video 1. Come on back, we'll do some examples in video 2, and that'll wrap up section 11.1.